You know, most AI models out there answer your questions the exact same way every single time. It's just one pass, straight to output. But what happens when you hit a wall? Welcome to This Explainer. If you're dealing with a broken database migration, maybe a formal math proof, or a really deep multi-step debugging session, that one-pass method, it completely falls apart. Today, we're breaking down Claude's Extended Thinking API feature. This is an incredibly powerful capability that fundamentally changes how the model processes your absolute hardest problems. Section 1. The problem with one pass. To really understand why this feature is such a game changer, we first have to understand the limitation of standard LLM architecture. When a model jumps straight to generating the final output, it's essentially trying to solve a massive, complex puzzle in a single breath. If it makes even one wrong assumption early on, that error just compounds into a completely useless, hallucinatory answer. So we have to ask the obvious question: what happens when an AI actually needs to think before it speaks? I mean, if you're trying to debug an intricate code base, you wouldn't expect a human engineer to just blurt out the first line of code without planning it out first, right? Yet, that is exactly what standard API calls force AI to do. Section 2. Enter extended thinking. And that brings us to the solution. Instead of jumping straight to an answer, extended thinking is a parameter you can add natively right into the Claude Messages API. It allows Claude to run multiple sequential reasoning steps internally before responding. It basically gives the model a scratch pad to work things out. And we really need to highlight the sheer scale we are talking about here, 10,000 plus. Claude can spend tens of thousands of tokens reasoning internally before it writes a single word of its final response. And with models like Claude Opus 4.8, that reasoning budget scales automatically based on the problem's difficulty.
Section 3. The Database Migration Fix.
Let's ground this abstract concept in a real-world scenario. Imagine your database migration is failing in continuous integration. You're trying to add a not-null column to a table that already has existing rows. Now, a standard AI without thinking often gives you a plausible-sounding but completely incomplete answer. But with high-effort extended thinking, Claude traces the migration's execution step by step against the existing data state. It catches that those existing rows have no value for the new column, which violates the constraint before a default is even established. Then, it delivers the concrete fix: either add a default false or run a two-step migration. It doesn't guess, it reasons.
Section 4. Anatomy of the API.
Okay, let's get into the technical mechanics under the hood. In your API request payload, you simply add a thinking object to your JSON. You set the type to adaptive and the effort to high, and just make sure your max_tokens parameter is set high enough to accommodate the process. Then, check out the response structure. Instead of just getting a standard text block back, the API returns an array. First, you get a thinking block that reveals Claude's internal work, and that is followed by the text block, which contains the final output that your user will actually see. Getting the mode right here is absolutely crucial because there's a major compatibility gotcha. There used to be a manual mode where you could set an explicit token budget, but do not use this for the newer models. It's actually deprecated on Claude Sonnet 4.6 and strictly blocked on Opus 4.7 and 4.8. It will throw a hard 400 error. Instead, you want to use adaptive mode. You just pass an effort level, low, medium, high, or max, and Claude decides how much reasoning each step actually requires. But I do have to give you a really critical warning. You are billed for all generated thinking tokens, and they bill at the exact same per token output rate as regular tokens. Because the model might generate thousands of invisible reasoning tokens before returning a super short text answer, your billed token count can be drastically higher than the visible output. You are paying for the work, not just the summary. Section 5. When to use it. Because of that cost implication, we definitely need to be smart about our architectural decisions. Consider this your decision matrix. You want to use high or max effort extended thinking for problems where an early wrong assumption is going to doom the whole task. Things like formal proofs, complex code debugging, architecture planning, and autonomous workflows, where the AI has to reason about tool results before deciding its next move. But crucially, skip this entirely for simple Q&A, summarization, or classification tasks. For those, standard mode is faster, it's cheaper, and the extra reasoning depth adds zero value. And here is a golden operational rule for you. If your thinking budget exceeds 32,000 tokens, use the batch API instead of synchronous calls. If you try to run massive reasoning tasks synchronously, you are absolutely going to hit connection timeouts. Not only does the batch API solve the timeout issue for these heavy loads, but it also gives you up to a 50% cost savings. It is a total win-win for intensive workloads.
Section 6. Key takeaways and next steps.
All right, we have covered a lot of technical ground really quickly. So here is your implementation checklist. First, always use adaptive mode for Claude 4 models to avoid those 400 errors. Second, make sure you set your max_tokens well above your expected volume, so you actually give Claude enough room to think. Third, and this is absolutely vital for multi-turn chats, never strip those thinking blocks out of the conversation history when passing context back to the API. And finally, monitor your billing closely, because you are paying for every single token the model thinks. Extended thinking effectively gives the model a scratch pad to reason step by step. If you want the full chapter on this, complete with 3 worked examples and common developer pitfalls, head over to claudemaster.net to check out the Claude Master ebook. But I want to leave you with this thought to wrap up our overview. If an AI can now seamlessly reason through 32,000 tokens of internal logic before answering, what complex pipeline problems in your own systems are you still stubbornly trying to solve in a single pass? Thanks for joining me on this explainer. I'll see you in the next one.